This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at surface area. Now, definition of surface area: if f and its first partial derivatives are continuous on closed region R in the xy plane, then the area of the surface S, given by z is equal to f of xy over R, is defined as surface area is equal to, and then our double integral over the region R, the square root of 1 plus the partial with respect to x, partial of f with respect to x squared, plus the partial of f with respect to y squared. So let's take a look at our first problem here. And number 1. Okay, so we're given f of xy is equal to 3x plus 3y. And it says find the area of the surface given by z is equal to f of xy over the region R. And it says R is a triangle with vertices. So let me actually draw that. 0, 0, 7, 0, 6, 7, 0, 3, okay, then we got this triangle here, and that's what we're working with. Well, first thing from our formula is we need partial of f with respect to x. So if I take partial derivative of this with respect to x, that gives us 3. And then we also need a partial with respect to y. That would give us 3. Again, when you're taking partial with respect to x, you treat the y like a constant. So that drops away, and derivative of 3x is 3, and then same here. Well, now we need to figure out our setup here. So this is going to go from x equals 0 to x is equal to 7. Put the x's on the outside. And we'll put the y's on the inside. And this is our surface area, by the way. This is S equals. So this will go from y is equal to 0. Here's y is equal to 0. Up to this line right here. So we need to find out what this is equal to in terms of y. Well, we're given 2 points here. So 0, 3, and then 7, 0. Well, we can find the slope between them. The change in y over the change in x. So 3 minus 0 over 0 minus 7, which gives us negative 3/7. And remember, our equation line is y is equal to mx plus b. We just said m was negative 3/7. And b is our y-intercept, which obviously our y-intercept is 3. So we got y is equal to negative 3/7 x plus 3. So that's our region of integration. Now remember, the numbers always have to be on the outside here. That's why I put 0 to 7. And then any variables you have to be on the inside. Well, then we've got square root of 1 plus the partial of f with respect to x squared, which was 3 squared, plus then the partial of f with respect to y squared, and that was 3, so this will be 3 squared. Dy dx. So this gives us x is equal to 0 to x is equal to 7, and y is equal to 0 to y is equal to negative 3/7 x plus 3. 3 squared is 9, 3 squared is 9, so 9 plus 9 is 18, plus 1 gives us 19. So we've got square root of 19. dy dx. Now, I can put the square root of 19 clear out in front so I don't have to worry about it. So we got s is equal to square root of 19. X is equal to 0 to x is equal to 7. And then y is equal to 0 to y is equal to negative 3/7 x plus 3 dy dx. Well, we'll work with the inner integral here. So we've got square root of 19. X is equal to 0 to x is equal to 7. And that gives us y, because there's like a 1 here. So the integral of 1 is 1y or y. From y is equal to 0 to y is equal to negative 3/7 x plus 3. Now we'll plug those in now. So we got s is equal to square root of 19. X is equal to 0 to x is equal to 7. Plug this in for y. So we're going to have negative 3/7 x plus 3 minus, and then we plug this in for y. So minus 0 dx. Well, now we want to integrate with respect to x. Well, add 1 to our power, divide by our new power. So we got negative 3/7 times x squared over 2 plus, and 3 becomes 3x. From x equals 0 to x equals 7. So we got s is equal to the square root of 19. And this gives us negative 3/14 x squared plus 3x. Simplify it a little bit. And now we're ready to plug in our numbers. So we've got square root of 19. We'll plug 7 in. So we got negative 3/14 times 7 squared plus 3 times 7 minus, and then I'll put parentheses because that minus has to affect everything that follows it, and I'll put 0 in for x. So we got negative 3/14 times 0 squared plus 3 times 0. Well, 0 squared 0 times negative 3/14 is 0. 3 times 0 is 0. So all that drops away there. So we got negative 3/14 times 49 plus 21. So square root of 19. And 14 and 49 are both divisible by 7. So that gives us negative 3/2 times 7 plus 21. Negative 3 times 7 is negative 21 over 2 plus, and I'll rewrite this as 42 over 2 to get a common denominator. Well, negative 21 plus 42 is 21 over 2, so this gives us 21 square root of 19 over 2 for our answer, assuming I didn't make any basic math error. Let me go ahead and save this. Surface area page 01.pdf. And let's look at our second problem here. We got our f of xy is equal to 3x plus 4y plus 5. And then our region of integration, set of xy values, such that x squared plus y squared is less than or equal to 9. Now, if I look at x squared plus y squared equals 9, that's a circle of radius 3. So if I come over here, it's going to be a circle of radius 3. And when we're talking about less than, you're talking about this region right in here. Now, whenever you have a circle, polar is an easier way to go, so we're going to be heading there. But First off, let's find our partial. We're going back to our formula. We need our partial with respect to x, which would be 3, and our partial with respect to y, which would be 4. Now, this is going to go from theta is equal to 0 to theta is equal to 2 pi, and this will be r is equal to 0 to r is equal to 3. Here's r is equal to 0, r is equal to 3 goes out to here, and then we're going from theta is equal to 0 to theta is equal to 2 pi, which is all the way around our circle. And inside here, from our formula, we need this. So we got square root of 1 plus the partial of x squared plus the partial with respect to y squared. And then remember, when we switch things to polar, we always have to put an extra r in here. So we'll put an r here, and then dr d theta. Well, let me take this, and this is S, our surface area. Let me take this out in front. 3 squared is 9, plus 1 is 10. Let me write it out. I'll make some kind of basic math error if I start skipping steps. So that's 1 plus 9 plus 16 r dr d theta. So then we got theta is equal to 0, theta is equal to 2 pi, r is equal to 0 to r is equal to 3. And 1 plus 9 is 10, plus 6 is 26, so we got square root of 26 r dr d theta. Well, the square root of 26 I can just put out in front. So we got S is equal to square root of 26, and then theta is equal to 0 to theta is equal to 2 pi. And we're left with an r in here. So the integral of r, with respect to r, is 1/2 r squared from r is equal to 0 to r is equal to 3 d theta. Actually, the 1/2 I can put clear out in front, so that would be give me 26 square root of 26 over 2, and now I'm left with r squared. And I'll go ahead and plug in these numbers. So I'm going to plug the 3 in for the r, so we got 3 squared minus, and I'll plug 0 in for the r, so we got 0 squared d theta. So 0 squared drops away. 3 squared is 9, and I can put the 9 out in front. So we got 9 square root of 26 over 2, and then from theta is equal to 0 to theta is equal to 2 pi. When you switch these to polar, it makes them so much easier. So then I'll have 9 square root of 26 over 2, and there's a 1 in here, so the integral of 1 is just 1 theta or theta. From theta is equal to 0 to theta is equal to 2 pi. A lot of books don't put the theta equals and r equals and so forth. I find it just makes things so much easier to keep track of. So we got S is equal to 9 square root of 26 over 2, and I'll plug 2 pi in for theta. So I got 2 pi minus, and I'll plug 0 in for theta. So we got 2 pi minus 0. The 0 drops away, and these 2's cancel, and my surface area is going to be 9 pi square root of 26. And that's our answer. So let me go ahead and save that. Let's take a look at our third one. We got f of xy. And these are all the same instructions, by the way. Find the surface area. F of xy is equal to 4 minus x squared And our region of integration says rectangle with these vertices. So let me go ahead and draw that. So we got 0, 0. We got 0, 2. 5, 0. And 5, 2. Okay. So our region of integration will be this right here. Okay. So let's go back up to our formula. What we need. Let me put my glasses back on. Okay. So then we need a partial respect to x. Well, this would become negative 2x. Now partial respect to y. There is no y here, so that's just 0. So now we're ready for our setup. And this is just a rectangle, so it's real easy in that regard. So we got x is equal to 0 to x is equal to 5. And we got y is equal to 0 to y is equal to 2. And then our formula says square root of 1 plus the partial respect to x squared. So I'm going to have this negative 2x squared. That's pretty sloppy. Let's try it again. So negative 2x squared plus a partial respect to y squared. And then dy dx. So this gives us x is equal to 0 to x is equal to 5. And y is equal to 0 to y is equal to 2 of square root of 1 plus 4x squared dy dx. Well, now we're going to find the integral, the inside integral, and it's respect to y. So there's no y here, so this just becomes, and I didn't put an s here, but this is s equals. So go x equals 0 to x equals 5. And then we put a y in front of this. That's just like a constant. That's how you treat it. And that'll go from y is equal to 0 to y is equal to 2. Now if we plug the values in for y, x equals 0 to x is equal to 5. We'll put 2 in for y. So we're going to have 2 square root of 1 plus 4x squared minus, and then I put 0 in for y. So I got 0 times square root of 1 plus 4x squared dx. Now the 0 times drops away. The 2 I can put out in front, so I don't have to worry about it. And we got x is equal to 0 to x is equal to 5. And we got square root of this, which I can rewrite as 1 squared plus 2x squared dx. Now I don't have this formula memorized from the. I looked up in the tables in the back. Over here, I'll put a note here. If I put it over here, I might have to work part of my problem over there. And that's why I put my glasses on, so I can write this formula down. This is from the tables. It's the integral of the square root of u squared plus a squared du is going to equal to the 1/2 times u times square root of u squared plus a squared plus the natural log of absolute value of u plus the square root of u squared plus a squared. Now, don't be afraid to use those tables of integration unless you're told otherwise by your instructor. Well, this is real close. I have to flip these two around so the u is first, but u would equal to 2x, then du would equal to 2dx, and a is going to be 1. Okay, well, we need a 2 inside, so I'll offset it with a 1/2 out in front. So we're going to have 2 times 1/2. X is equal to 0, x is equal to 5, and we're putting the 2 inside. And I'm going to flip those around, so this will be 2x squared plus 1 squared dx. And now we can do our u substitution. Now out in front, 2 times 1/2 drops away. And this will be x equals 0 to x is equal to 5. Up here we said 2dx becomes du, and this becomes the square root of u squared plus a squared du, which matches our formula exactly. So now we can just use this. So we're going to have, let's see, 1/2, then parentheses u square root of u squared plus a squared plus natural log of the absolute value of u plus square root of u squared plus a squared from x equals 0 to x equals 5. Well, now we want to plug our u back in. And our a. U we said was 2x, and a we said was 1. Now that 1/2, let me see, is that in front of everything? Yeah, it's in front of everything. So the 1/2 I can put out in front. And u we said was 2x, and then this will become 2x squared plus a squared, which gives us our original 4x squared plus 1, plus the natural log. Now when I put 2x in here, the square root is always positive. If I put 2x in here and I'm going from x equals 0 to x equals 5, these absolute value bars aren't necessary anymore. So this becomes 2x plus the square root of 4x squared plus 1. From x equals 0 to x equals 5. I'm going to continue it up here. We're now ready to plug in those numbers. So I'll plug 5 in for x. So I'm going to have 2 times 5 square root of 4 times 5 squared plus 1 plus the natural log of 2 times 5 plus the square root of 4 times 5 squared plus 1 minus, and I'll put parentheses here because that's affect everything that follows it. Now plug 0 in for x. So I got 2 times 0 times the 4 times 0 squared plus 1 plus natural log of 2 times 0 plus the square root of 4 times 0 squared plus 1. There we go. Equals 1/2. 2 times 5 is 10. 5 squared is 25 times 4 is 100 plus 1 is a square root of 101. 25 times 4 is 100. Okay, yeah. Plus natural log of 10, 2 times 5, plus square root of 101. Minus 2 times 0 is 0 times the square root is 0, so that drops away. 2 times 0 is 0 here, so we got minus natural log. 0 squared is 0 times 4 is 0 plus 1 is 1, so square root of 1. Like that. Which gives us 1/2 times 10 square root of 101 plus natural log of, and I'm missing a parentheses here, aren't I? That should be a parentheses right there. ln of 10 plus square root of 101 minus square root of 1 is 1. Natural log of 1 is equal to 0. So I could multiply this 1/2 through if I want. 1/2 times 10 gives us 5. So we've got 5 square root of 101 plus 1/2 natural log of 10 plus the square root of 101. It's possible they might take this 1/2 and put it as a power, but I'm going to go ahead and stop there. That's our surface area. Now that one is a little bit of a tricky one. Let me go ahead and save that. There's other ways you could find that integral, but I just decided to use table to make it fairly simple. Though you can see it wasn't too simple. Okay, let's look at our fourth one. We got our f of xy is equal to the square root of x squared plus y squared, which is also, keep in mind, x squared plus y squared to the 1/2 power. And then our region of integration, is going to be between, 0 is less than or equal to f of xy is less than or equal to 4. Well, this region of integration, considering f of xy is this right here, let me plug that in actually. X squared plus y squared is less than or equal to 4. And my eyes kind of went askew when I was working this problem earlier. I didn't know square root. Because if I think of the equals, this is square root of x squared plus y squared is equal to 4. If I square both sides, we get x squared plus y squared is equal to 16. So it's a radius 4. Goes around like that. And then our region of integration is going to be less than, so of course it's what's inside. I worked that problem earlier, and I didn't even notice the square root. I was thinking it's radius 2, but it's not. It's radius 4. Well, it's a circle, so polar is our best way, but we still have to find our partial respect to x, partial respect to y. Partial respect to x, if I take this is parentheses to a power, take my power, put it out in front, what's inside the parentheses remains as is, lower my power by 1, and then you multiply it times the partial derivative with respect to x. The y squared drop away, it's a constant, and derivative of x squared is 2x. So this is going to give us, these 2's will cancel, and you got x over, and take this back down below here. So that's x squared plus y squared to the positive 1/2, which is x over the square root of x squared plus y squared. Partial respect to y will be 1/2. Take your power, put it out in front. What's inside your parentheses remains as is. Lower your power by 1 times the partial derivative of what's inside with respect to y. The x squared is a constant, so it drops away. Derivative of y squared is 2y. So that's going to give us, those 2's cancel again. We've got y over x squared plus y squared to the 1/2 equals y over the square root of x squared plus y squared. And now we're ready to do our setup. So our surface area, theta is equal to 0 to theta is equal to 2 pi, goes all the way around the circle. And then we're going to go to r is equal to 0 to r is equal to 4. And remember our formula. Well, I've shown enough times, I think you got it. 1 plus a partial of x squared partial respect to x squared, sorry. So this will be x over square root of x squared plus y squared squared plus the partial respect to y squared. So we got y over square root of x squared plus y squared squared. Whoops, almost screwed that up. I always forget to put that extra r. Remember, we'll have to put an r here. Now this is a little bit sloppy, how I'm doing this. The reason why I'm not switching those x's and y's to r's and so forth is because it's all going to drop away anyway. Because if I look at this, and if you didn't spot that and you started switching, it might be a really hideous. So you might try to simplify this first. When I square this, that gives me x squared over, and you square this, the square root and the second power cancel, and you get x squared plus y squared. Plus, I square this, and I get y squared over x squared plus y squared. R dr d theta. Usually I simplify that up above, but I wanted to follow the formula to a letter, but still not work hard. If you look at this, these have the same denominator. If I put them together, add top parts, I get x squared plus y squared over x squared plus y squared. So that becomes 1 plus 1. Like I say, try to simplify it first before you start switching things to r's and thetas and so forth. You may find it just it's super easy. Well, 1 plus 1 is 2, so that's square root of 2, and I can go ahead and put that out in front. Theta is equal to 0, theta is equal to 2 pi. Now here we're left with r. Well, the integral of r is 1/2 r squared. Well, with respect to r, I should say. R is equal to 0 to r is equal to 4. Now that 1/2 I can put clear out in front, so we're going to have s is equal to square root of 2 over 2. And now we'll plug these values in. So I'll put 4 in for r, so we're going to have 4 squared minus, I'll put 0 in for r, so we've got 0 squared. D theta. Well, the 0 squared drops away. 4 squared is 16, and I can put that clear out in front. So I'm going to have 16 square root of 2 over 2. And theta is equal to 0. Theta is equal to 2 pi d theta. Well, 16 divided by 2 is 8, so we got 8 square root of 2. The integral of this just gives us theta. Remember, you have a 1 here, so that's 1 theta or theta. From theta is equal to 0 to theta is equal to 2 pi. So then we're going to have s is equal to 8 square root of 2. And I'll plug 2 pi in for theta. So I got 2 pi minus, and I'll plug 0 in for theta. Well, that 0 drops away, and 8 times 2 is 16 pi square root of 2 is our answer. Now that one's an interesting one. A little bit disappointed myself for screwing it up in the first place, but oh well. I just didn't notice that the radius was 4. So let me go ahead and save that. And let's look at our next problem. Actually, let me grab a drink. Where's my pop? There it is. This one's a little bit different on the setup. Number 5 says find the area of the surface. Still the same formula. And it says the portion of the plane z equals 10 minus 5x minus 2y in the first octant. First octant, everything's positive, so that's important to keep in mind. X starts at 0, Y starts at 0, Z starts at 0. And now the plane keeps going forever, but again, all we're looking at is just the part of the plane that falls in the first octant. Now I put a hint down here, and it's not quite what I want to say, but For the region R, let z equals 0, and then use that to solve for y and solve for x, and then find equation line. It's a little bit confusing how I wrote it there. Okay, so we got z equals, which is the same as f of xy, is equal to 10 minus 5x minus 2y, like that. And to see what it's bounded by, we're going to come over here, and we'll start with the y's. Now for the y's, if I put 0 in for z, I'm going to have 0 is equal to 10 minus 5x minus 2y. And now we want to solve for y. So I take negative 2y over, so we've got 2y is equal to 10 minus 5x. Divide everything by 2, and we get 5 minus 5/2 x. Now for our x's. Now z is gone, y is now gone, so we put 0 in for y. And we're now left with 0 is equal to 10 minus 5x. Then if I take the negative 5x to the left side, becomes a positive 5x, divide both sides by 5, and we get x equals 2. Now for our formula, we need to partial respect to x, which would be a negative 5. We need to partial respect to y, which would be a negative 2. Now from our formula, we'll put x equals 0 to x equals 2 here. Remember, your numbers have to go on the outside. And then I go from y is equal to 0 to y is equal to 5 minus 5/2 x. Now we could have done that differently. I could have put the y's on the outside here, in which case I would have approached it entirely differently. I still would have done this, but then I would have solved for x. And then over here I would have put 0 in for x, and I would have 0 equals 10 minus 2y. So it'd be fine to do that way. I just chose this approach. Now remember, this is the square root of 1 plus a partial respect to x squared, so we got negative 5 squared, plus partial respect to y squared, so we got negative 2 squared. And then we got our dy dx. And that's the surface area. Well, negative 5 squared is 25, negative 4 squared is 4. 25 plus 4 is 29, plus 1 is 30, so we'll take the square root of 30 and put it out in front. And from x equals 0 to x equals 2, and then y is equal to 0 to y is equal to 5 minus 5/2 x. dy dx. I work with this inner integral. So I'm going to have s is equal to the square root of 30. X is equal to 0 to x is equal to 2. This is like an invisible 1 here, so the integral of 1 is 1y or y. Y is equal to 0 to y is equal to 5 minus 5/2 x dx. So square root of 30. X is equal to 0 to x is equal to 2. And now plug these in for y. So put 5 minus 5/2 x in for y. So 5 minus 5/2 x minus, and I'll put 0 in for y, dx. Now that 0 is going to drop away. So then, take the integral of this. 5 becomes 5x minus 5/2 times integral of x is x squared over 2, from x equals 0 to x is equal to 2. Let's do a little bit of simplifying first. So I got s is equal to square root of 30, 5x minus 5/4 x squared. X equals 0 to x equals 2. 2 times 2 gave us 4. And now we're ready to plug in our numbers. So we've got square root of 30. I plug 2 in for x. So I got 5 times 2 minus 5/4 times 2 squared minus, and now I'll put 0 in for x. So I got 5 times 0 minus 5/4 times 0 squared. I got square root of 30. 5 times 2 is 10. 2 squared is 4, and it cancels that 4, so that's minus 5. Minus, and all that gives us a big 0. 0 times 5 is 0. 0 squared is 0 times 5 fourths is 0. So our surface area, 10 minus 5 is 5, so that'll give us 5 square root of 30 for our answer. Let me go ahead and save that. And let's take a look at our last problem. Now this just wants us to set it up. Doesn't want us to actually solve it. In order to solve these, they have to make them fairly simple. If you don't, they give you integration that you can't do by hand anyway. And not all of them you can use tables on. So they have to really be picky about the setup on these. Otherwise, they just say set up the integral. And our region of integration is going to be a rectangle with vertices -3, -5. 1, 2, 3, 4, 5. So -3, -5. -3, 7. 1, 2, 3, 4, 5, 6, 7. 4, -5. 2, 3, 4. 4, -5. And 4, 7. Okay, so this is going to be our rectangle. Boy, that's really bad there. Good drinking before I create these, I guess. Normally I'd say good enough, but that's just a little bit out there. 3, -7. Oops. I normally can't draw a straight line anyway, but that was too much. Okay, so that's our region of integration. Well, first thing we need to do is find our partial with respect to x. So we only worry about the part with x's in it. It's y to the 5th we can treat as a constant, so it drops away. So the partial derivative with respect to x is going to be 8x minus 5y. This one, remember, we treat the -5 and y like constants, and derivative of x is 1, so that drops away. Now we'll do the partial with respect to y. The 4x squared is a constant, so it drops away. And this gives us -5x plus 5y to the 4th. Now since we've got a rectangle, it's pretty straightforward. We're going to have x is equal to -3 to x equals 4. That's our x values. It goes from -3 to 4. And our y values, it goes from -5 to y is equal to 7. -5 to 7 in terms of our y values. And our formula says we're going to have 1 plus the partial of x, partial with respect to x squared. So we're going to have 8x minus 5y squared plus the partial with respect to y squared. So we've got -5y plus 5y to the 4th squared. dy dx. And again, all they're asking for is a setup, so that's our answer right there. You can see as I've made the problem more complex, actually integrating that would be horrible. Wouldn't fit any form in the back of our book in terms of the tables. Only thing we could do is numeric integration anyway. So I'm going to save that. I believe that was our last problem. Yeah, it was. So surface area.